Okay, good afternoon students. Today we are going to discuss about the photolithography. Let me introduce myself. I am Neha Sharma, Assistant Professor at Department of Electronics and Communication Engineering at Engineering College Jhalawad, Rajasthan. So this is the syllabus of RTU for your 8th semester IC technology subject. So starting 3 units we have already covered some part of third unit, and this fourth unit we are going to discuss. This is pattern transfer and etching process. It includes following contents like introduction to optical and photolithography, contact and proximity printers, and mask generation, what are photoresists, and finally etching and dry and wet etching. Different type of etchings we'll use. Now why this pattern transfer is required and why we want to do this etching process. This is basically when you have to build some structure like gate structure, and let me tell you, like this is our say substrate, and this is our source and drain region. So whenever we are doing the fabrication, it is a layer process. One by one layer we have to grow. So after this thing, if we want to make a gate structure, it should have a SiO2 layer here and this polysilicon layer on the top of it. And let me indicate it as my source, drain, and this is my gate. So to build this type of structure, we need to do a lithography process. That is, some pattern we have to transfer it here. Some pattern we have to make it here, where there should be some this SiO2 layer here and one upper layer above. So for this thing we are doing our this lithography process. So what is a photolithography? It means photo means light, and litho means stone, and graphy means writing, means stone writing sort of. So it is basically a pattern transferring on semiconductor materials, and this transferring and this writing thing we are doing with the help of a light. That's why this is known as photolithography. So patterns are first transferred to an imageable photoresist layer, and these terms like what is a photoresist and this exposing, which light we should use for this, we are going to discuss these things in our subsequent slides. So photoresist is basically a liquid that can be applied on a substrate, and when it is exposed with a desired pattern, and when it is developed, some sort of design has been created on your substrate, and whichever the portion we need to keep, we will keep it, and rest of the portion we will etch away. Etching means removal of unwanted thing, is known as basically etching. So all these diagrams that I am going to use in this slide are taken from VLSI technology book written by SMZ. So I have not removed the captions so that all the students can refer it back from the book. That is a really very good book that you should refer for this subject. So this is basically how this mask is there is a pattern on the mask, and it is transferred on an unpatterned wafer, and this unpatterned wafer, this whole printing thing. So mask is basically a blueprint which is very large in size, but the wafer we know that as the technology is reducing, your mask size is also reducing. Your one die is in some few centimeters, and on it you have to make transistors which is of micrometer size. So of course this very large size mask has to reduce up, and finally that reduced one is what we known as reticle. So this is happening, this transfer of IC patterns from mask to a silicon wafer. As you can see here, this small is that pattern. So this is basically a photolithographic transfer process. Then first process is we have an SiO2 layer over our substrate, and then we have applied a photoresist in our second step, Now, what is a photoresist and what are the types of photoresist we are going to discuss. You just think that it is a chemical that is needed to be applied on it, which will make some portion as hard and some portion as soluble whenever it is exposed to light, and that light is UV radiations we are taking here. So we are applying a photomask here, as you can see in the third step, and UV radiations away above it, and then after exposure some pattern has been formed in figure 4. You can see this is our developed image. Then in fifth step we are doing the etching process, that is the unwanted material that is below this dick form, it has been removed. And in the sixth one the photoresist has also been removed. So this is your basic lithographic transfer process. As I already told you, there are two type of photoresist. One is your positive photoresist and one is your negative photoresist. We are going to discuss in coming lectures and in coming slides. So this is one question in this diagram, in this picture, which type of photoresist we have used, so that some portion which is exposed to UV radiations has been removed and some part of it has been retained. So which type of photoresist that you should this is a sort of quiz question from this slide. Moving on, what are the basic lithographic process that we are going to do? So starting from incoming wafers here, starting from the incoming wafers, first we should need to apply the photoresist, and then pre-bake option we have, then printer align expose, here we will apply the mask, and then it is developed and rinse and dry, and then we have to do the post bake. Basically pre-bake and post bake are done so that your photoresist can easily be retained on your substrate and will not be removed. Then we will inspect and measure the size, like how much micrometer or nanometer of your layer you want. So then your outgoing wafer will be etched, and then strip resist means it is removal of extra resist. Removal of extra resist we will do here, and then finally deposit or grow a new layer on it. So next is photolithography process. Like I told you in the previous graph, like first we have to do the surface preparation, then we have to coat our photoresist on it, then we have to do the soft baking, then the alignment is basically with the mask. Alignment is with the mask. Then exposure with your UV lights, then resist development, let it develop for some time, and then resist development is basically depending upon your positive and your negative photoresist, like which one will become hard and which one will become soft. Then next one we have hard baking, then processing using photoresist as a masking film, then stripping means removal, and then finally cleaning of your surface. These are the steps involved in your photolithographic process. Next one is your photomask. We have discussed in your previous slides also what is actually a photomask. Photomask is nothing but like I told you before, it's just like a blueprint which is very large in size. So when it is exposed to light, its size reduces, and you have to basically draw all the patterns on your chip, which is basically of your micrometer or nanometer technology. Nowadays 7 nanometer technology size has reduced up to. So that much of reduction in size we have to do, and such things can be done by your photomask. So photomask are made up from glass emulsion plates like Kodak high resolution plate HRP, and your glass covered with hard surface material. Emulsion masks are actually a little expensive, so it can make a feature size of 5 micrometer region. Let me tell you what do you mean by feature size. What do you mean by feature size? Feature size is basically the smallest gate. Actually, when we talk about technology, we say technology is 2 lambda. So basically that is the minimum size of minimum feature size, minimum size of any like source, drain or gate that you can build, the minimum size of a channel that should be there. That is your actually feature size. Means anything should not be less than your technology size. And any structure that you are building, any design that you are building on your substrate, it should not be less than your feature size. That is the smallest size. Okay. So all the electron beam generated masks are made up of hard materials such as your chromium oxide, iron oxide or silicon. These masks are basically much more expensive, and it is giving you a benefit that the feature size here is reduced to your 1 micrometer. So that is done for today's lecture, that we have discussed about your photolithography process, your photomask, how it is done. And I have given you one question also regarding the photoresist. In the next lectures, we'll discuss like what are the types of photoresist, positive or negative photoresist, how it is developed, and how we can apply the processes by which we can apply a photoresist on your substrate. This is we are going to discuss in your subsequent lectures. And yeah, good for today. Have a good day.